All right. So today we're doing linear inequalities. So just like we can solve linear equations by using properties of expressions, whatever you do on one side, you do on the other, right? So commutative, associative, distributive, as well as properties of equality. We can use the same thing for inequalities. However, I told you yesterday there's only one difference. We did this on our warm-up. There's only one difference, and the difference is when you multiply or divide by a negative, you have to do what? Okay, let's check. So the first one says, consider this true inequality. Is 4 truly less than 8? Is that true? Let's look at a number line. If I were to just sketch a number line really fast, the number 4 is right here, 5, 6, 7, 8 is right here, 3, 2, 1, 0. Which number is closer to 0, 4 or 8? 4. So 4 is less than 8. This is true. Okay. What if we added 3 to both sides? So what if we took our inequality and added 3 to both sides? That's what it's asking us to do. Do we still get something that's true? Let's see. 4 plus 3 is 7, and 8 plus 3 is 11. Is 7 less than 11? Yes. So that is also true. What if we subtracted 4 from both sides? So 4 minus 4 is less than 8 minus 4. Let's see, 4 minus 4 is 0, and 8 minus 4 is 4. Is 0 less than 4? Yes. So we just showed that the properties of addition, whatever you, like equality, whatever you add to one side, you have to add to the other. Whatever you subtract from one side, you have to subtract from the other. We just showed that that is true, right? We just proved that. But what about if we multiply both sides? Let's see. 4 times 2, is that less than 8 times 2? Well, 4 times 2 is, and 8 times 2 is. So is that true? Yeah, it is true. What if we divide both sides by 2? So the original inequality was 4 is less than 8. And I'm going to divide both terms by 2. Let's see. 4 divided by 2 is, and 8 divided by 2 is. That's also true. Okay. Kylie, put it down, please, and thank you. All right. So based on exercise 1, you might conclude that the truth values of inequalities have the same properties as equations. But there's a huge difference. So we're still going to use this 4 less than 8 concept, only now we're going to multiply both sides by negative 2. We're going to multiply both sides by negative 2. So negative 2 times 4 is negative 8. And 8 times negative 2 is negative 16. So is negative 8 less than negative 16? No, because when we talk about less than, we talk about like which one is closer to 0, right? So 16 is much farther from 0 than negative 8 is. So this is not true. This is false. And we learned yesterday that when you multiply or divide both sides by a negative, you have to do what? What did we say yesterday? You all were in here yesterday. Yeah, flip the inequality sign. Do you guys remember doing that in our warm-up? Okay. So this property of inequalities just says, hey, you can add the same thing to both sides and it'll still be true, and you can subtract the same thing from both sides and it'll still be true. However, when you multiply or divide by a negative, you have to, so only when you multiply or divide by a negative number do you have to flip the inequality. Flip the inequality. So this says write a true inequality and show that it becomes false when you multiply or divide your choice each by a negative. So someone just give me an inequality. Just make up some inequality that you know is true. Like 10 is greater than 2. Something like that, but don't use that one. Say again.
7 is greater than 5.
Okay. 7 is greater than 5. Okay. So what do you want to multiply both sides by? It's got to be a negative number. Negative 2. Okay. So we know that this is true, correct? You guys feel 100% confident that 7 is bigger than 5? Okay. So now we're going to take that idea of 7 being greater than 5, but we're going to multiply both sides by, Ariana chose negative 2. And when we do that, we get negative 14 is greater than negative 10. Is that true? Let's look. Yeah. Negative 14 is right here. Negative 10 lives about right here. And 0 would be right here. So this is not true. So we just proved, again, that you have to do what to make it true? When you multiply or divide by a negative, you have to do what? Good job. So if we flip the inequality, we actually end up with negative 14. The flip of greater than is less than negative 10, and that is true. Okay? So that's just the whole understanding of why we have to flip the inequality. It's because we're multiplying by a negative. All right, so let's solve this inequality. So I have 4x minus 3 is greater than or equal to 5. So what would you do if you're solving just like you would solve for x? What's the first thing that you're going to do? Ken, what's the first thing that you're going to do to get, whoa, I hate it when that happens. What's the first thing that you're going to do to get x all by itself, Ken? Not yet. Not yet. We got to get, what do we got to move away? That, and it's a negative 3. So what's the opposite of negative 3, Ken? Positive 3. So the first thing that we're going to do is add 3 to both sides. So 4x is greater than or equal to 8. Then we divide both sides by 4. X is greater than or equal to 2. Step B says write 5 numbers that make this true. So what are 5 numbers? So we're looking for 5 numbers that are greater than or equal to 2. We need to come up with 5 numbers that are bigger than 2 or equal to 2. Give me one. Daniel, one number that's greater than 2 or equal to 2. 4. Okay, someone give me another one. Oh, we don't want to graph 1 million. 6, okay? Brianna, give me a number that is bigger than 2 or equal to 2. 7, okay? Aiden, give me a number that's bigger than 2 or equal to 2. Perfect. One more, I need one more. What's another number, Avery, that's larger than 2 or equal to 2? 9, perfect. I love that. So those 5 numbers would make that inequality true. We have to graph this inequality. So remember yesterday we talked about this. When you have the greater than equal symbol or the less than equal symbol, is your circle that you plot on the number line going to be filled in, or is it going to be like closed, or is it going to be open? Closed. So I'm going to plot a closed circle on the number 2. So if this is 0, this is 1, 2. Closed circle. And I want all of the numbers that are bigger than or equal to 2, so I'm going to shade to the right. All of the numbers that are greater than or equal to 2, so I shade to the right. And then the numbers that you gave us, let's see, we said the number 2 fell in that solution set, and it does. We said the number 4 fell in that solution set, and it does. We said the number 6 is part of the solution set, and it is. We said number 7 is part of the solution set, and we also said number 9 is. Okay. Aiden, you gave us the number of 1 million. Is 1 million in that solution set? Is the number 1 million bigger than 2 or equal to 2? Yeah. We just don't want to have to draw our graph out to a million spaces, right? That would be horrific. But we know that that line goes on forever. So any number that's bigger than 2 all the way up to infinity. Does that make sense? Okay. Now let's look at this inequality. 8 minus 2x is greater than 16. So 8 minus 2x is greater than 16. What would you do first, Kenna, if you were trying to get x all by itself? What would you do first? What do you have to move away from the x side of the inequality? The 8. Is that a positive 8 or a negative 8 right now? So I have to use the opposite operation, which is minus 8. When I do that, this becomes negative 2x, right? Don't forget the negative sign in front of your term, right? That negative is part of it. And 16 minus 8 is 8. Next step. What do you want to do next, Owen?
I want to divide both sides by 2, by negative 2.
Good job. We're dividing by negative 2. So I'm going to put a little note here that says you are dividing by a negative, which means you have to flip your inequality. You're dividing by a negative, which means you have to flip your inequality. So let's see, negative 2 divided by negative 2 is 1, so that just leaves me with 1x. And positive 8 divided by negative 2 is negative 4. But I have to flip my inequality. So instead of it being greater than, it is now going to be less than. Good job. So this says just pick any number. Let's just pick any number. We just want one number that's going to make, like, that would be true to this. So give me a number that's less than negative 4. Yes, sir. I'm going to use negative 6 because that's what Daniel said. So we're going to use the number negative 6, and we're going to plug it into our inequality. And we're plugging it into the original. And we're going to see if it works. Sorry, I can't spell today. Okay, so meaning I'm just going to let x equal negative 6, and I'm going to plug it into this original inequality that we had. So that's 8 minus 2 times, what are we letting x equal? Negative 6. Daniel chose negative 6 is greater than 16. Let's see, 8. What is negative 2 times negative 2? Sorry, what is negative 2 times negative 6?
Positive 12.
A positive 12 is greater than 16. Let's see, 8 plus 12 is 20. Is 20 greater than 16? Yes, it is. This is true. So we're going to graph this solution. The x is less than negative 4 right here on this number line. So we always begin at the number that is part of the solution. So negative 4 is where we begin. Remember that when we use the less than or the greater than circle, or greater than symbol, is our circle going to be open or closed? Open. So I'm going to find negative 4. Let's see, this is negative 1, negative 2, negative 3, negative 4. I'm going to put an open circle. And I want all of the numbers that are less than negative 4, like negative 6 that Daniel gave us. Negative 6 lives right here, so that means I shade to the left. I shade to the left. Okay. Do you remember yesterday we said that when you have an inequality, shade in the direction that the inequality points? Does that make sense? Do you see how the less than symbol points to the left? Okay. Our last example. Look at this inequality. Whew. Oh my goodness. So this is definitely a multi-step inequality. It looks horrific. What is the first thing, if we're using the same properties that we would use to solve an equation, what is the first thing that you would do, Lissandro? If this was your problem, what's the first thing you would do? Distribute. Yeah, we need to get rid of all these parentheses so we can see exactly what the heck is going on here, because this is a hot mess. So 8 times x is 8x. 8 times negative 2 is negative 16. Good job. Negative 3 times 2x is negative 6x. Negative 3 times a positive 1 is negative 3. My symbol, less than or equal to. Nothing is happening to the 7x. I'm just going to rewrite it. Nothing is happening to the positive 4. But now we need to distribute right here. Negative 3 times x is negative 3x. Good job. And negative 3 times positive 1 is, we're multiplying. What's negative 3 times 1? Negative 3. Good job. So let's see. I'm going to kind of just draw a squiggle here. I can combine my x's. What is 8x minus 6x?
2x.
It's 2x. Good job, Owen. And what is negative 16 and negative 13? The signs are the same, so I add them together. See, it's 19. Negative 19. Good job. Say again. Did I say 13? Oh, sorry. Okay, so negative 16 and negative 3 give me negative 19. Sorry. Let's combine on the right side. 7x and negative 3x equals 4x. And a positive 4 and a negative 3 end up giving me a positive 1. Okay, so let's solve this inequality. We want the x's on the left. We always want the x's to be first. So I need to move the variable term over to the left side. I want the variable term over to the left side. How am I going to do that?
Well, first of all, you're going to subtract 2x on both sides.
I'm actually going to subtract 4x, and here's why. I want the variables on the left. I always want my inequality to be x is greater than, so I want the x's on the left. 2 minus 4 is negative 2x. So I have negative 2x minus 19 is less than or equal to 1. What do you want to do next, Kylie? If I have negative 2x minus 19 is less than or equal to 1, what would you do next? You're trying to solve this inequality. What would you move away to get x all by itself? What's on the same side of the inequality as the x term that you can move away? And it's negative, right? So what's the opposite of a negative? Good job. So we're going to add 19 to both sides. We're going to add 19 to both sides. So negative 2x is less than or equal to 20. Victoria, what do you want to do next? Divide both sides by negative 2. Uh-oh. What are we doing? Yeah, we're dividing by a negative. What does that mean? Flip it. So x is now greater than or equal to, what is 20 divided by negative 2? Negative 10. It asks us to graph this. So I just want to show you, whenever you have to sketch a graph of an inequality, the only number I ever put on my number line is the number that's given as the beginning part of the solution set, negative 10. It's the only number I ever put on there. Is this going to have an open circle or a closed circle, and why? Isaac, open circle or closed circle? Why? Because? Good job. Closed circle because of the bar underneath the inequality. Which way am I going to shade? Which way is my inequality pointing? To the right. Shade to the right. Okay. Good job.